Hello friends. Hello friends. Welcome back to my channel. In today's video, I'll be talking about terminology used in networking techniques for project management, and then I will also be talking about rules that are used while drawing a network diagram. Okay, so networking techniques. Under this, today I'll be talking about terminology used in this techniques, and I'll also be talking about rules. What are the rules that are to be followed to draw a network diagram? Okay. So networking techniques involve all those networking techniques. They involve representing all project activities as a network. So in networking techniques, all the project activities, they are represented as a network. And then after these activities are represented on a network diagram, next is you will be finding the total duration that is required for completing the project. Then these techniques, networking techniques, also involve leveling of resources by adjusting activities. So whatever resources are available during the progress of project, those resources will be leveled by using these networking techniques. So networking techniques, they are used for planning, scheduling, and controlling of the projects. So you can use this networking techniques for planning various project activities. You can use those techniques for scheduling various project activities, and you can also use those techniques for controlling the project so that project moves on the right track and it gets completed within its stipulated time and within its stipulated budget. So networking techniques, they, as I said, they are used for completing the project in its stipulated time. Then these techniques, they are also used for optimum utilization of the resources. Whatever resources are available, those resources will be used in an optimum way. For using them in an optimum way, you can use networking techniques. Okay, so networking techniques, we have understood three different uses for these networking techniques. One is planning, scheduling, and controlling the projects, and then the second one is completing the project in its stipulated time and also in its stipulated budget. By how are you going to ensure that uh, the project gets completed within its stipulated budget? By ensuring optimum utilization of the resources. So you can use networking techniques for all these three. You can take tasks. Then networking techniques, I'll be talking about two types of networking techniques. One is critical path method, which is simply abbreviated as CPM. And then the other networking technique that we are going to talk about is program evaluation and review technique, which is simply abbreviated as PERT, P-E-R-T. Okay. So on this slide, what we have learned or what we have understood that networking techniques, they involve representing all project activities as a network. They involve determination of total project duration, and they also involve leveling of resources by adjusting the activities. Then these networking techniques, they are used for planning, scheduling, and controlling projects. They are used for completing the project in its stipulated time. They are used for the optimum use of or optimum utilization of the resources for project completion. Then we will be talking about two different networking techniques. One is critical path method, and the second one is program evaluation and review technique, which is PERT. Okay. Now, next thing that I'll be talking about is, let us understand the terminology that is used in these two networking techniques, CPM, critical path method, and PERT. What are the terminologies? What are the terms that are used? What various terms are used uh, in these two techniques? First, let us understand event. So, what is this event? Event represents start of the process of completing a distinct operation, or you can say a distinct activity. So event will represent the start of the process by which an activity will be completed. Okay, so event is the start of the process of completing a distinct operation, or you can say a distinct activity, a distinct project activity. Okay, it can occur at any instant in time. So when you talk about event can occur at any instant in time. An event is represented by a node on the network diagram. So in my previous video, I have talked about arrow activity on arrow diagram and activity on node diagram. So in that I have discussed the concept of node. So over here, event, it will be represented by a node. It will be represented by a node on the network diagram. It will be represented by a node on activity on arrow diagram, activity AOA diagram, AOA type of network diagram. So event will be represented by a node. Okay, so for example, if you have the activity, the first activity in the project is, let us say, activity A. So as per definition of event, we are saying that event is nothing but start of the process of completing a distinct operation. Operation is nothing but activity. Okay. So the process of completing activity A starts over here, and that we are going to represent it by a node, and that node will represent event. So an event is represented by a node on network diagram. Which type of network diagram we are talking about? We are talking about activity on arrow type of network diagram, AOA diagram. So on AOA diagram, event will be represented by a node. So in this case, in this particular example, event 1 will represent the start event for activity A. And once activity A gets completed, we will have the end event for activity A. Let us say that it is 2. So on this simple AOA diagram, where we have represented activity A on the arrow, one node 1, it represents the start event for that activity, and node 2 represents the end event for activity A. Okay, so event is the start of the process of completing a distinct operation. Then it can occur at any instant in time. An event is represented by a node on the network diagram. Which network diagram? Activity on arrow network diagram. And over here, I have shown a simple example to make you understand what is an event and how to represent it. Okay. If two or more operations are ending on a node, let us say there are two activities, and these two activities gets completed simultaneously. So on the network diagram, they will be represented in this way. Those two activities, two or more than two activities, those activities will be ending on a node. Okay. Then when this happens, then the node that comes into picture, that node is called as a merge event. From the name itself, you'll get an idea. It is that event where two or more than two activities are terminating, or two or more than two activities are getting completed. So that node is a merge event. Similarly, if two or more operations start from a node, if a particular node represents start of two or more activities, then that node is you call that node as burst event. You call that node as burst event. I have shown it with an example. So let us say this is a node, and now since three different operations or three activities are getting completed at this node, you are calling this node as merge event. So you can clearly see more than two activities, like this activity is ending, getting completed at this node, this activity is getting completed at this node, and this activity again is getting completed at this node. So in this case, this particular node is representing a merge event. Now you can clearly show a burst event. So burst event will be represented by a node from which two or more than two operations start, or two or more than two activities start. Okay, so in this case it is a burst event. Okay, so on this slide you have understood the concept of event. You have understood how it is represented on AOA diagram, and then you have also understood the concept of merge event and burst event. So let us proceed. Then the other you can say concept that you have to understand is successor event or successor events. Event or events. It could be one successor event or it could be more than one successor events. So what is that? An event or events that follows another event. So we are talking about an event that is coming after some other event. Okay, so that's why we have defined it like this: an event or events that follows another event. So I have shown in this diagram. So for example, this is event 1. Event 1 represents the start event for activity A, and then activity A gets completed at event 2. Okay, then event 2 acts as, or for the simple diagram, what is to be understood in this case, event 2 is occurring after event 1, or event 2 follows event 1. Therefore, event 2 is a successor event. Okay. Then as you have successor event, you also have predecessor event or predecessor events. So how it is understood? It is understood as an event or events that occur before another event, any other event. So we will understand this with the help of this simple diagram. So you have event 1, which is the start event of activity A, and this ends at event 2. Activity A ends at event 2. So in this particular case, you can say event 1 is predecessor event of event 2. So event 1 is a predecessor event. Predecessor of which event? It is predecessor event of event 2. Okay. So on this particular slide, you have understood the concept of successor event, and you also have understood the concept of predecessor event. Now let us move ahead. Next thing that you have to know is what is an activity. How is an activity defined on the network diagram? So how to define it? An activity is nothing but a distinct operation that is to be done during the progress of a project. Okay. So this is a distinct operation, an operation which you can define and which you can perform independent, uh, which you can perform it in a distinct way. So that particular operation, you call it as an activity. So this is a distinct operation that is to be done during the progress of a project. Activity consumes time and resources. So when this is again important for an activity, this is true. Every activity, every project activity, it will consume time and it will also consume resources. On a network diagram, now let us talk about how it is represented. On a network diagram, an activity is represented by an arrow between two events. Now we are talking about a AOA network diagram, that is activity on arrow diagram. So an activity on an activity on arrow diagram, an activity will be represented by an arrow. I have explained this in my video on AOA and AON diagram. You can just watch it and understand the concept. So on that diagram, on AOA diagram, an activity is represented by an arrow between two events. So for example, um, we'll discuss the example after some time. The direction of the arrow that we are going to use for representing an activity. The direction of the arrow indicates the direction of progress, project's progress. So if this arrow is representing an activity, the direction of this arrow will show the direction of progress of the project. So that's why we are saying direction of the arrow indicates the direction of the project's progress. The length and shape of the arrow have no meaning. So what what is the length of the arrow, then what is the slope of the arrow, what is the shape of the arrow, it all this do not have any meaning on the network diagram. The length and shape of the arrow, it has no meaning on the network diagram. So for example, let us say this is event 1, you have event 2, and the arrow between these two events will be represented or it will be representing an activity. So for example, in this simple diagram, again I'm repeating the same example so that you understand the concept. So you have event 1, you have event 2, and between these two events you have an arrow that is representing activity A. So in this particular diagram, again I'm saying event 1 is the start event, or activity A starts at this event and activity A aims at this event. ठीक है? So event 1 is the start event of activity A, and event 2 is the completion of activity A, or you can say event 2 is the end event for activity A. End event represents completion of an activity. ठीक है? So on this diagram you have understood the concept of an activity, and you also have understood how an activity is represented on AOA diagram. Okay, next thing that we have to understand is successor activity. So as you had successor event, you also have successor activity. The definition or understanding of successor activity is similar to uh, what we have understood in case of successor event. Okay, so what is a successor activity? An activity that can only start after the completion of one or more activities. Okay, so we are talking about that activity which will only start when either one or more than one activities get completed. So in that case, the activity that we are talking about will be the successor activity. So for example, this is event 1, start event of activity end event of activity A. So at event 2, activity A ends, and after completion of activity A, activity B starts, and it gets completed at event 3, and then activity C starts and it gets completed at event 4. So for this simple diagram, how can you understand which one is the successor activity? In this case, you have two activities that will come after activity A, or that will come after the completion of activity A. So in this case, activities B and C, these two, they are successors of A. Okay. So that was the concept of successor activity. So as you have successor activity, you also have predecessor activity or predecessor activities. And the simple understanding is, predecessor activity is an activity that must be completed before next activity can start. Okay, so if a given activity is to start, then there are some one or more than one activities that must be completed. All those activities are called as predecessor activity. Okay, so for example, even let us talk about activity A. Activity A starts at event 1, it ends at event 2. Then after that, activity C starts and it ends at event 3. So in this particular simple diagram, activity A is the predecessor activity of B. In other words, predecessor activity of predecessor activity to in this particular example, we have talked about activity C. So this is activity C. So you can see it in the diagram. So if you look at the diagram, before you start activity C, activity A should be completed. In other words, activity C can only start after A gets completed, and that's why activity A is the predecessor activity of activity C. Okay, so this is how you can understand predecessor activity. Now you know what is a successor activity, and now you also know what is a predecessor activity. Then the next concept that we are supposed to understand is dummy activity. So what is this dummy activity? An activity that consumes neither time nor resources. So while understanding the concept of activity, we have learned that every activity will consume time and resources. But now we are talking about a dummy activity. Dummy activity is that activity which will neither consume time nor it will consume any resources. It is non-real activity. So from the name itself, you can say it is a non-real activity. But why it is used? It is used to preserve the logic of the network diagram. So in order to preserve, in order to make the network diagram logical, make the network diagram look logical, we can use this dummy activity. But the point to remember in this case is, dummy activity will neither consume any time nor it will consume any resources. Now let us consider the following activities. Let us understand the concept with an example. So you have different activities. So in one column, in the first column, I will be listing various activities, and in the second column, I have listed immediate predecessor activities. Okay, so for example, activity A, B, C, D, and E. So we have 5 different activities, and then let us talk about the predecessor activities. So for activity A, B, and C, there are no any predecessor activities, whereas for activity D and E, um, A and B are the predecessor activities, and for activity E, B and C are the predecessor activities. Okay, so what can happen, since A, B, and C, all 3 activities, they don't have any predecessor, so they can simultaneously start. So activity A is starting, simultaneously activity B will start, and then activity C will start. Okay, so since this 3 A, B, and C, these activities don't have any predecessor activity, they can start simultaneously, or there will be one start event for all the 3 activities A, B, and C. So instead of using small letters, let us use capital letters since. So you have activity A, you have activity B, and then you have activity C. All three have started simultaneously. The reason is all these three, they don't have any predecessor activity. Activity A aims at event 2, activity B aims at event 3, activity C aims at event 4. Okay. Now the other concept. Now next, before you can start activity D, the condition is activities A and B, they should be completed. So accordingly you have to show. So activity A is getting completed. So after that, after the completion of activity A, D, activity D will be starting. Let us use capital D. Activity D will be starting. Okay. Then the other condition is the predecessor. Both A and B are predecessor activities to D. That means D can only start when both A and B are completed. So that means A A completes at event 2, B completes at event 3, and in order to preserve the logic, in order to show that both A and B gets completed and then activity D starts, we are using this dummy activity. Okay. So if you look at the network diagram, activity A is getting completed, activity B is getting completed. After this two gets completed, activity D is starting. So here we have used a dummy activity to preserve the logic of this particular network diagram. Okay. Now similarly, activity E is going to start after B and C gets completed. So after C is getting completed, C gets completed at event 4. So event 4 will be the start event for activity E. Let me use a capital letter since we have listed those activities by using capital letters. So that's why I am using capital letter on the diagram as well. Okay. So you can easily tell how the dummy activity will come into picture in this case. In order to preserve the logic, we'll have to use a dummy activity over here. So once the dummy activity is used, now you can clearly understand that for starting of activity E, B should be completed. B is getting completed at 3, and then C should also be getting completed. C is completing at 4. So event 4 you have both B and C getting completed, and then activity E starts at event 4. Okay. So in this way you have used two dummy activities on this network diagram. The motive is to preserve the logic. Once you have those dummy activities, then finally activity D and E, after these two activities you don't have any other activity, so they can simultaneously get completed at event 5. Okay. So this is how you can use dummy activity on a network diagram. So what you have to remember about dummy activity, they are used only to preserve the logic of the network diagram. They neither consume any time, neither they consume any resources. It is a non-real activity as we have stated over here. Okay. So this is how you have to make use of dummy activities on a network diagram. Okay. So this red dashed arrow, it represents dummy activity. The point is the dummy activity on a network diagram will always be represented by a dashed arrow, a dashed arrow like this. Color doesn't matter. Here, in order to make it distinct, I have used the color, but it will always be represented by a dashed arrow. Okay. So this is the concept of dummy. Then next concept is concurrent or parallel activities. So what are this? These are activities that are performed simultaneously. All those activities that can be performed simultaneously, you call those activities as concurrent activities or parallel activities. So these activities either start or end at the same node. Or in other words, this concurrent or parallel activities, they have either common start event or they have common end events. The other way of understanding it is this concurrent or parallel activities, they either start or end at the same node. So for example, you have event 1 activity A ends at event 2, and then you have activity B which starts at event 2, ends at event 3, and now you have activity C which starts at event 2 and ends at event 4. So in this particular diagram, if you look at activities B and C, these two activities are starting from the same node. They have the same start event, event number 2, and therefore activities B and C, these are parallel activities. Okay. So after understanding this, um, the important terminologies that are used in network techniques or in network diagrams. Now let us understand few important rules that are to be followed while drawing a network diagram. First, first rule is an event is represented by a node. We have understood that. An activity is represented by an arrow. So we are here. We are talking about AOA network diagram. Activity on arrow network diagram. AOA network diagram. So we are discussing rules of drawing an AOA diagram. So what are the rules? First rule is, on this diagram, an event will be represented by a node. An activity is represented by an arrow. What is a start event? A start event is the node from which an activity arrow originates. Start event. What is an end event? End event is the node on which an activity arrow terminates. So again, I have there is one example. So you have event 1. At event 1, and then you have event 2 and then activity A. So in this diagram, again, this is, I have discussed this example many times so that you can understand. So in this case, A is an activity, 1 will be the start event for activity A and 2 will be the end event for activity B, activity A. Okay. So uh, what is a start event, what is an end event, you have understood on this slide. Next is, the start event is represented by the lowest number on the network diagram. So when you draw the network diagram, you will be numbering the events, and start event will be that event which will be represented by the lowest number. Okay, so start event is represented by the lowest number on the network diagram, and end event is represented by the highest number on the network diagram. Again, this is straightforward. The activity emerging from the start event has no predecessor activity. So for example, over here, so you have event 1, activity A starts at event 1. So 1 is the start event for activity A. Activity A is emerging from 1, which is the start event, and therefore activity A has no predecessor activity. So an activity which does not have any predecessor activity, that will be the start, that will start at the start event. So will be one will be representing the start event in this case, and then this the first two rules that I have talked about. So if this is the start event, it will be represented by the lowest number, and if this is the end event, it will be represented by the highest number on the network diagram. So in between these two events, we'll be having different activities. So you have to remember this. Then next is the activity terminating at the end event. Again, it is straightforward. You have the end event, and we are talking about that activity which is terminating at the end event. So naturally, sorry, naturally that activity will have no successor activity. So for example, if this is the last event, and if activity n is terminating at event 10, which happens to be the last event in the network diagram, then n will have no successor activity. Activity n will have no successor activity. So if 10 is the end event, activity n terminates at 10, and therefore activity n will have no any successor activity. Okay. The next rule is event should be numbered in an increasing order. It is straightforward. So you start at the start event and you stop at the end event. So as you move from start event to the end event, you number those events in an increasing order. You start at 1 and then you go on like 1, 2, 3, 4, 5 and 10, the last event. So the point is, while numbering events on the network diagram, you have to follow an increasing order. You start at the start event, give lowest number to the start event, then go on increasing the numbers. When you come at the end event, give the highest number to that event, end it. That is what you have to understand. For an activity, a lower number is given to the tail event and a highest number is given to the head event. Now we are talking about an activity. Okay. So for example, let us again talk about activity A. So for activity A, 1 is the tail event and 2 is the head event. The other way of understanding it. This is the start event, this is the end event. Similarly, this is the tail event, this is the head event. Okay, so for activity A, 1 is the tail event and 2 is the head event. And if you look at those numbers, tail event is represented by the lowest number. So out of 1 and 2, 1 is the lowest. So we are representing tail event by the lowest number. Okay. Then a network diagram cannot have more than one start or end nodes. Again, this is important. So when you draw a network diagram, you make sure that there is only one start event, not more than one start event. Similar, same thing for the end nodes or end events, only one. If there are more than one start or end nodes, or you can say one more than one start or end events, what you do, this should be reduced to one. And how are you going to reduce it to one? You are going to do that by adding appropriate number of dummy activities. Use dummy activities to make the start event equal to 1 or end event equal to 1. Okay. So for example, let us say that 1 dash and 1, these are two start events. Then in order to make the network diagram logical, what we will do, we are going to use a dummy activity. So if activity A is to start only if activity A has is going to have two start events, 1 and 1 dash, then 1 and 1 dash will be represented on the network diagram by using this dummy activity. Okay, so this is one rule. Then there should be no loop in the network diagram. Again, this has to be followed. So for if you have loop in the network diagram, what is going to happen? The project will never end. You'll just go on moving in the loop, and the project will never end. So for example, event 1, activity A starting at event 1, activity A ending at event 2, activity B starting at event 2, activity B ending at event 3, and activity C starting at event 3 and ending at 1. So in this particular network diagram, in this simple network diagram, you have a loop, and if you have a loop, the project will never end. And that's why care is to be taken. What care? Avoid there should be no loop in the network diagram. Okay. Then next rule is an event cannot occur unless its predecessing activity is completed. Okay, so if you have event 2 and event 1 start event of activity A, event 2 end event of activity A. Now event 2 is going to occur only when activity A gets completed. So event 2 will not occur unless activity A is completed. Okay, so that's why you have this rule. An event cannot occur unless its preceding activity is completed. Okay, the next rule is an activity cannot start unless its preceding activity is completed. Again, it is very simple to understand. You have activity A, start event of activity A, end event of activity A. Then activity B is starting at event 2, it is ending at event 3. So in this case, activity B can occur only when activity A is completed. Okay, so activity B cannot start unless activity A is completed. So this is true, this particular rule, this is true even for the dummy activity. Okay, so in my next video, I'm going to discuss this numerical. Uh, I'll just show you. So you have different activities. I'm going to discuss this in my next video. So for time being, I'll end this video. In this video, we have understood various terminology used in network diagrams, and then we have also understood important rules that are to be followed while drawing a network diagram. We have specifically talked about activity on arrow diagram. Okay, so thank you for being with me. You please subscribe to my channel, watch my videos. Earlier in my previous video I have talked about activity on arrow and activity on node diagram. You please do watch them and please subscribe to my channel. And if you have any doubts, you please mention those doubts in the comment section. And then you also please hit the bell icon so that you will be notified as soon as I upload a new video. Thank you for being with me.